We are starting here a topic that is temperature and distribution of temperature. Now it's very clear that we have discussed lot of things about temperature till this part of our lectures, but somewhat we can say that we have to summarize here whatever we discussed earlier, and we have to use certain terms. So you may feel that this lecture is repeated lecture or some sort of revision lecture. So you can consider nearly 70 to 80% discussion is there with you. Already we have discussed that. Some 20% to 30% new things we are discussing here. Now Earth is receiving radiant energy from Sun. That is the only major source of energy for Earth. It is not considered that moonlight is, again we can consider, but moonlight is really very less as compared to whatever energy received by Sun. Again, energy given by Sun is either reflected or radiated by Moon, and so it is again energy of Sun only. Distant stars are there, but whatever their contribution to our energy is very less. In internal matters like activities of volcano or magma, they are there to give some sort of heat, but in case of Earth we have to depend maximum on Sun for this energy. In previous lecture we discussed about heat budget. There we discussed that whatever radiant energy or Sun is giving us energy, that is reflected back by Earth. So whatever input, if 100 units input is there, then 100 units output is there, and that's why Earth's temperature remains constant. This is all we discuss. Now here whatever energy is radiated by Sun, that all energy is not received by Earth. Sun is radiating energy in all possible directions. Let us check out here. This is Sun. It is emitting energy in all possible direction. I am showing here in terms of plane, but practically it is three-dimensional. So this way, all these directions as well as backside, everywhere we are getting the radiation from Sun. Now out of that, suppose Earth is here. With compared to Sun, this is the shape of and size of Earth. So only this energy is there for Earth. Remaining all energy is lost here in the space. This arrangement is there so that Earth can move around Sun, and every time we are getting energy. That energy, whatever received from Sun to Earth, that is 1 upon 2000 millionth. So million means into 10 raised to 6. So this much of energy is received by Earth from Sun. So whatever Sun is emitting energy per minute or per hour or per second, out of that, suppose 100 units are emitted by Sun, then 100 divided by 2000 into 10 raised to 6. That energy is given by given to Earth. So this is very less. Now here we are using a concept that is called as, now whatever energy is given by Sun to Earth, or say anyway, we can say the energy given here. We discussed this diagram also. This is surface, this is incident radiation. What happened to this incident radiation? Incident radiation is when interacting with surface, we have different probabilities as we discussed earlier. Part of light that is reflected back. Part of light is simply absorbed by this. So I am writing here with A. And part of light is transmitted by the surface. So this way, by changing path, obviously, because when medium is changed, the path is changed, that is called as refraction. So some part of light is transmitted. Let us take this example. Suppose a windshield, or say whatever the front glass of car is there. that glass, you must have observed many times that directly we are getting reflection from that glass, particularly sunlight is reflected, we are getting some flash like appearance for that. So that radiation is reflected by glass. That means if these units are 100, then all 100 units are not passing out through glass. Part of that light is reflected. Even on building also you must have seen that glass windows are there. From that also sunlight is reflected. But it is not 100% that is reflected. So part is reflected. Part is transmitted. And that's why through glass we can see whatever is the opposite side of that glass. So that is, we are saying transparency of glass. So light is transmitted. And part of light is absorbed by glass. What is the evidence? You can check out by touching this glass. You will get hot surface. If glass is becoming hot, that means what? Some part of radiation or radiant heat is absorbed by that glass. So this way, on surface, these three actions are there. Suppose sunlight is coming on water body, then also these all three things are possible. Number one, part of light is reflected back. You must have seen radiations or reflected light from water. Otherwise, we are not able to observe water. And as we are able to observe water, that means part of light is reflected back. So that is reflected back. Part of light is absorbed by water and whatever inside water. Let me clarify. Phytoplanktons are there. These are green, say having chlorophyll, and they are absorbing this light. Even water is absorbing light, and that's why temperature of water rises. So this is the reason during daytime we are getting hot water. This is because of water is absorbing radiations. So here that radiations are absorbed by water. And third, it is transmitted. You are aware that continental shelf, part under the sea, where depth is around 100 fathom or less than that. What is characteristic of 100 fathom? Because sunlight is able to reach till 100 fathom. That reach till means what? The light is reaching till, that means it is transmitted. So these all things are possible for light. Even you can check out if you have aluminium foil. What wrapper of chocolate is there? Usually that golden color or whatever color is there, metallic part, that is called as aluminium foil. You can check out through aluminium foil you can observe sun. That means aluminium foil is not 100% opaque. Part of light obviously reflected back, part of light is absorbed, because that's why if you keep that wrapper in sunlight, it get hot. And third thing, if you observe sun through it, you can able to observe, that means part of light is transmitted. So these three things are there depending upon the variation. Say for example, if in case of basalt rock, the color of basalt rock is going more towards black. I am not saying it is perfectly black, but more towards black. That means whatever the incident radiations are there, reflected back radiations are very less. Now in case of basalt rock, you are aware it is having dark color, black color we can say, but technically speaking almost black color. It is not 100% black, because you are aware that no perfect black body is there. And so we are saying it is almost grayish, but towards blackish side. So what is the meaning of that? Whatever incident radiation, incident means whatever the radiation is coming on it, out of that very less is reflected back. Remaining, that is either absorbed or transmitted. Now can radiation transmitted through rock? Answer is, if you are considering layers of rock, then from that in upper layer it is transmitted. Every layer is dense, it is absorbing light, and so ultimately whatever transmitted, that is also absorbed. So I should say that maximum radiations are absorbed and very less radiations are reflected back. As a result, heating effect of rock is much more greater than water, because water reflects more, whereas here the maximum light is absorbed here. If you are talking of land covered by snow or ice which is having white color, then obvious thing is that maximum radiations are reflected, some radiations are transmitted also to greater depth. So absorption amount is considerably less, and that's why heating effect is something different in that case. Now here, whatever the light that is reflected back by surface, that is called as albedo. I am revising concept. Whatever light reflected back by surface, that is called as albedo. Albedo is more if color of light, color of surface is white. Albedo is less if color of surface is black. That's why if you observe certain parts of India where regur soil is there, what is characteristic of regur soil? It is having dark color. Titaniferous magnetite is name of substance which is present in that soil, which gives us dark color to that soil. It absorbs more radiations. If you are talking of greater Himalaya, where maximum land is covered by ice or snow, then in that case albedos are more than plateau of Deccan, because on plateau of Deccan you will get maximum regur soil. So these effects are there, that is of soil. Now try to recollect our radiation part. We discussed that there are various radiations, but I have to give idea here once again, because I must explain here what is the meaning of long radiation and short radiation. Almost I am revising this twice or thrice. This is energy diagram. So energy axis, highest energy radiations, here we are giving what is known, that is gamma rays, then X-rays, then vacuum ultraviolet, then ultraviolet, then violet, indigo, blue, green, yellow, orange, red. So this range we are calling as VIBGYOR, that is visible range. Then onwards infrared, far infrared, microwave and radio waves. I hope this chart we discuss in physics, basic physics, and in geography also we discuss this chart. Here till red, whatever radiations are here, we are calling these as short radiations. They are ultra short, but here I am simply calling these as short radiation. Whereas these radiations, they are called as long radiations. Now, incident radiation, that is sun is giving us energy, that radiation, gamma rays are given by sun. But you are aware the range of gamma rays is very, very less. They are absorbed in upper parts of atmosphere only. X-rays are also given by sun. But again same record, that range of X-rays very, very less, so they are also absorbed in upper parts of atmosphere. Vacuum ultraviolet, as name indicate, they have existence only in vacuum. The moment they enter in atmosphere, they get absorbed by atmosphere, so they are also absorbed by upper part of atmosphere. Then ultraviolet radiation, you are aware now that all ultraviolet radiations are not absorbed by ozone layer. It is wrongly said that ozone layer absorb ultraviolet radiation. A part of ultraviolet radiation which is harmful for life, that is absorbed by ozone. Otherwise ultraviolet radiations are coming directly on surface of earth. What is the best evidence or example I can give here? That D vitamin, that is synthesized by our skin from morning sunlight, and there we discussed that morning sunlight is having ultraviolet radiations that is required for synthesis of D vitamin. That means ultraviolet radiations are coming on surface of earth. You can check out if you are having fluorescent dye, that means suppose t-shirt is having fluorescent color, or some bands are there, they are giving you fluorescent color. Even paintings, they are made in fluorescent color. If that fluorescent color is there, it is appearing more bright, that means there is presence of ultraviolet radiation. If ultraviolet radiations are absent, then fluorescent color will not appear fluorescent. So in which light fluorescent color appear more fluorescent, that is consisting of ultraviolet light. So our spectrum, or whatever the sunlight is there on surface of earth, part of ultraviolet is absorbed by ozone layer. Not all ultraviolets are absorbed by ozone layer. Again in chemistry you must have come across some reaction, that is methane reacting with chlorine gas in presence of diffuse sunlight. Why diffuse sunlight? Because in diffuse sunlight ultraviolet radiations are there. That means ultraviolet radiations are present on surface of Earth. Sun is giving that also. Then visible radiations. Visible radiations are very little bit absorbed by atmosphere. Maximum visible radiations are coming to surface of Earth directly. Evidence, we can observe this universe from our Earth, that we are able to observe sun, moon. That means what radiations are reflected or given out by these celestial bodies, they are reaching to surface of Earth. That means they are not absorbed or very rarely absorbed by surface of, by atmosphere. That means only these initial radiations are absorbed. Then onwards radiations are simply transmitted. But the surface of Earth, that absorbs all these radiations. Whatever the incident radiations are there, whatever radiations reaching on surface of Earth, they are absorbed by surface of Earth. No doubt, part of that radiation also reflected back by Earth, but a maximum part of that radiations are absorbed. As a result, surface of Earth is getting hot. Hot bodies are radiating heat. This is called as radiant heat or radiation given out by surface. Maybe surface is covered by ice, maybe surface is covered by water. You may say, why surface is covered by ice will give out heat? Keep in mind, temperature of ice may be minus 30 degrees Celsius, minus 40 degrees Celsius. What is the coolest place on surface of Earth? That is Antarctica, particularly South Pole, of which is located at altitude of around 3000 meters. That is the coolest place on surface of Earth. Gives minimum temperature minus 89 degrees Celsius approximately. Now, what is the minimum temperature in universe possible? That is minus 273 point something. That is 15 and remaining numbers are there. We can consider here minus 273 degrees Celsius. So, minus 273 degrees Celsius is called as absolute zero. Below that temperature one can't go. And so, with reference to that, ice or say minus 30 degree, minus 40 degree temperature, that is actually hot. And that's why even ice is considered as hot body. It is also radiating energy. These radiations are in form of infrared light. And that's why, if you are aware, thermal cameras or thermal sensor camera, they are working, particularly we are calling this as night vision camera. So in night vision camera, there is no light, but still we can carry out imaging with help of this type of heat or thermal sensors. So here that thermal sensor or whatever that is radiating, that object, every object, if its temperature is greater than minus 273 degrees Celsius, then it emits infrared radiation. Now in our geography, we are calling this part as long radiation. So surface is absorbing short radiation and radiating long radiations. Now, long radiations are absorbed by atmosphere, particularly carbon dioxide, methane and water vapors. They are absorbing long radiations. As a result, the gases near surface of Earth start out heating. And that's why in atmosphere, as we are approaching to the surface of Earth, temperature is more. As we are moving to a higher altitude, then temperature decreases. Try to recollect, we call this as lapse rate. In troposphere, this lapse rate is around 160 meter. If you move, then temperature falls by 1 degree Celsius. So around 160, 165 meter, 1 degree loss of temperature is observed. This is called as lapse rate. So it is present in troposphere. So troposphere is you are aware now, it is just adjacent part of surface till 8 kilometer on polar region and 16 kilometer in equatorial region. This is there. This is called as troposphere. Here we are getting this type of reflection, the heating effect, that as we are moving higher altitude, temperature falls. And that's why this is important factor in determining temperature. If particular location is at higher altitude, we will get less temperature. If we are at sea level, then temperature is obviously more, because sea level, that is we are considering as level to measure out. Now apart from that, it depends upon another factor. We are calling that as continental effect or maritime effect. Two names are there, simultaneously we have to discuss, but for that purpose I have to discuss another concept that is called as specific heat. Obviously this all part is related with science, no doubt. I am teaching here geography, but all these parts, they are there related with science, particularly physics. Specific heat is heat required to rise temperature of substance by 1 degree Celsius. Alright, just simple definition. Specific heat is heat required to rise temperature of surface by 1 degree Celsius. Now if specific heat, I have to define more clearly, then the definition is, it is heat required to rise temperature by 1 degree Celsius from 14.5 to 15.5 degrees Celsius. This particular range they are considering. For water, specific heat is very high. It is 1 calorie per gram or 1 kilocalorie per kilogram. For other substances, usually specific heat is less. Metals, specific heat is still less. What is the meaning of that? If I am supplying 1 kilocalorie energy to 1 kilogram water, then temperature of water will rise by 1 degree Celsius. Suppose a metal is there which is having specific heat 0.3 kilocalorie per kilogram. That means I am supplying 1 kilocalorie heat, then its temperature will rise by nearly 3 degrees Celsius. And so by giving little bit heat, rise in temperature will be more. Now in case of land, which is consisting of sand, soil, rock part, generally all these objects are having specific heat less than 1 degree Celsius, 1 kilocalorie per kilogram. So we are getting same quantity of heat on land as well as water. Water will take more time to get temperature high, but land will get hot fast. This is a scientific reason why land get hot fast than water. Now suppose you are there around water body, or water is there around you. For example, where we are staying, I am staying in Mumbai. Mumbai is surrounded by water. What is the impact of that? Water is taking more heat and more time to get temperature rise, and that's why in daytime water is not getting hot fast, and so daytime there is no much rise in temperature. Don't say there is no rise in temperature, but suppose I am comparing Mumbai and Delhi, then obviously the daytime temperature of Delhi should be more, or rather I should consider Nagpur rather than Delhi. What is the reason behind that? That Delhi is having towards temperate zone. Nagpur is there in tropical zone and around same latitude. Around, I am not saying on same latitude. Now Nagpur is having same temperature supposed to be, but no, it is heated because it is surrounded by land only, and so specific heat of land is less, so it is heated fast. You can check out during summer period that Nagpur can have temperature easily more than 40 degrees Celsius. But Mumbai, not easily 40 degrees Celsius. Very hot summer in Mumbai may have temperature around 38 degrees Celsius during daytime. During night time, land is losing out heat fast because specific heat is less. So more heat is lost during night and landmass get cooled down fastly. Whereas water will take more time to get cooled down, and that's why water, if surrounded your city or place is surrounded by water, then night time you are not getting much fall in temperature. So in case of Mumbai, in summer, if maximum temperature is around 38 degrees Celsius, then minimum temperature is around 28 to 30 degrees Celsius. It is not that maximum temperature 38 and minimum temperature of day will be 10. No. But these cases are observed particularly if you are there inside the continent. So where is the location? If you are there away from water body, then we are calling this as continental effect. So Nagpur is having very high temperature during summer. The reason is that is because of continental effect. One of the reason is there continental effect. Whereas in case of Mumbai, we are having almost similar temperature, not much rise in temperature. That is because we are calling as maritime effect. Converse is also there. In winter season, check out temperature of Nagpur, it is very cold. But check out temperature of Mumbai, it will never go below 10 degrees Celsius. Only in 50 years, past 50 years, once it falls till 8.5 degrees Celsius, we are calling this as very cold winter in Mumbai. But otherwise, average temperature in winter is around 12 to 14 degrees Celsius. If temperature goes below 12 degrees Celsius, we are calling that Mumbai is suffering cold. This is the case. So this is the effect of water. We are calling this as maritime effect. So these two effects, they are also there for this water. Now, temperature depends on albedo also. If albedo is more, temperature should be less. If albedo is less, then temperature should be more. Say for example, snow. If it is fresh, then fresh snow reflects almost 90% radiation. So whatever incident radiations are there, 90% radiations are reflected by snow. Whereas it depends on angle also. Angle means incidence angle, this angle. If this angle is less than 75 degree, then albedo is more. If this angle is either 90 degree or near 90 degree, another concept we are using perpendicular and near perpendicular, or 90 degree and near 90 degree, then reflected amount of light is less. Check out. This is the zone. Suppose I am saying light is coming in this way. This distance, suppose say 2 centimeter distance is there. This is the surface. So check out, you will get here wider surface. The same beam is falling on wider surface, and that wider surface that is reflecting out light. Now suppose radiations are perpendicular. I am keeping same distance over here around. Check out here, the surface getting is very less, and so we are getting more reflection over slanted angle and less reflection if near perpendicular or perpendicular is there. Now dry sand surface, that gives albedo amounting to 35 to 45%. That means in desert we are getting more light is absorbed and temperature rises. That is there. Whereas dark moist soil, that means regular soil we can consider, that reflects only about 15% light. That means 85% light is absorbed, albedo is just 15%. Even if forests are there, you are aware deciduous forest, where leaves of that trees are large, they are absorbing maximum light, and at that time albedo is just 5 to 10%. Whereas in case of conifers, conifer means needle shaped leaves are there, then albedo is in range of 10 to 20%. Albedo means reflected light. So reflected light depends upon nature of forest, nature of leaves. But grasslands are there, then grassland can reflect around 15 to 20% light back. So it depends what is the nature of a part. Say for example, it is covered by grass, it is having deciduous forest, it is having conifers. Depending upon that, reflection is there. If bare land is there, then what is the type, that is sand is there or black soil is there, depending upon albedo is there. We are focusing on temperature zones. As you are aware that vertical sun rays or near vertical sun rays, that means perpendicular and near perpendicular sun rays, they are having more heat, whereas slanted, that means angle is not 90 degree, sunrise angle, then that is having considerably low temperature. And on the basis of that, we discussed in previous lecture only about temperature zones. But here I had to revise that temperature zones. So you are aware this is 66.5 north, that is called as Arctic Circle, whereas this is 90 degree north, this means this is North Pole. These are called as higher latitude. Why higher latitude? Because it's 66.5 and till 90 degree. So they are called as higher latitude. Then this is 23.5 north. This is called as Tropic of Cancer. Then obviously equator 0 degree. Another line I should consider here, that will range here 5 degree north and 5 degree south. This is equatorial region. Then 23.5 south, that is Tropic of Capricorn. And last 66.5 degrees south and 90 degree south, this is South Pole, where this is Antarctic Circle. This is called as Arctic Circle, therefore this is called as anti-Arctic. So Antarctic Circle. So these lines are there. Now here this part receives sunrays throughout the year, either perpendicular or near perpendicular. So this part we are having always hot, supposed to be. Now remaining part I am showing here. This zone, that is between two tropics, so Tropic of Cancer to Tropic of Capricorn, this zone is called as tropical zone, where tropical zone is having average temperature very high. I am using word here average temperature. Whereas next zone, that is here, this is called as temperate zone, where moderate temperatures are observed, not much high and not much low. Then another zone is there, this is called as frigid zone. So towards this part we are getting here a zone that is called as frigid zone. So this way we are dividing Earth into these zones. I am revising again, 3 zones are there. The first, these 2 zones we are calling as frigid zone. So this is first zone, that is frigid. Then temperate zone, and lastly here we are getting tropical zone. No doubt I am saying this all, but still you may observe certain different things. For example, in case of India, part of India is there in tropical part. Say in case of Gujarat, run of Kutch is there. From that Tropic of Cancer pass out. Total there are 7 states in India through which Tropic of Cancer pass out. So below Tropic of Cancer it is tropical part, and above Tropic of Cancer that is temperate zone. So Delhi, then Amritsar, these cities are there in in temperate zone, whereas Mumbai, Tamil Nadu, or say Chennai, these cities are in temperate tropical zone. Say whatsoever that, we are getting almost similar temperature. I am not saying same, similar categories of temperature. Reasons are different, but still in Indian subcontinent highest temperature is observed, that is there in Pakistan. The place is Jacobabad, where highest temperature is observed, and it is there in temperate zone and not in tropical zone. So if you compare Chennai or even Kanyakumari, Kanyakumari is towards southmost point of mainland India, then also the highest temperatures are observed in Jacobabad, that is in temperate zone. So only sun rays are vertical or slanted, that factor is not working over here. Several other factors are also working over there. Now altitude is important factor. We have to take out average temperature of the place. Say for example, I am again coming to Mumbai. You may say, why we are again and again going? Because I am staying at Mumbai, so I am more familiar with whatever the weather climatic conditions are there of Mumbai. Mumbai is at sea level also. So we have to consider, suppose Mumbai. The nearby city is Pune. Almost on same latitude. I am not saying on same, almost on same latitude. So both cities should have similar temperature condition. But practically speaking, the thing is that Pune is there inside the continent, whereas Mumbai is at coastal line. Another thing, Pune is having higher altitude, whereas Mumbai is having lower altitude, almost sea level Mumbai. What I should do? I should consider that for every 160 meter height, temperature decreases by 1 degree Celsius, that is lapse rate. Pune is at 500 meter altitude. For sake of convenience, take out 480 meters altitude. So what I had to consider, suppose average temperature of Pune is 20 degrees Celsius. I had to decrease 3 degree. Why? Because 480 divided by 160. So it is 3 degree. So actually Pune is showing temperature that is 17 degrees Celsius, and Mumbai is having temperature, I have to increase, not decrease, I have to increase temperature because Pune is at high altitude, and so it is showing low temperature. If Pune is at sea level, then what temperature it should show? So I have to add 3 degrees, so we are getting average temperature at 23 degrees Celsius. So like that, I had to manipulate altitude wise. So this is called as altitude correction. And then I have to point out on map temperature of various parts or various places. And then I have to join these places together where similar temperature is observed. That is called as isotherm. Iso means same, therm means temperature here. So isotherm, that is the line joining out the places on Earth's surface having similar temperature. But in that case, altitude correction is required. Now these are called as isotherm. And then whatever you are observing, that is global pattern of isotherm. It is almost running latitude wise, almost, not exactly on latitude, because other factors are also there. Usually isotherm shifts northwards during month of July and southwards during month of December. Now we are focusing on another concept, that is vertical distribution of temperature. You are aware about lapse rate. So in tropical zone, lapse rate is there at 165 meter altitude, temperature falls by 1 degree Celsius, or at around 160 to 165 meter, temperature falls by 1 degree Celsius, supposed to be. But see what happens, that when air at surface get heated and that air start moving in upward direction, then there is expansion in air. Say for example, this is the surface. On surface, maximum pressure is there. So atmospheric pressure is maximum at surface. As we are moving away from surface, atmospheric pressure decreases. For this also we can consider, if you use barometer using mercury, then you are aware at sea level, 1 atmospheric pressure, that means 760 mm of mercury. At 160 meter altitude, mercury level falls by 1 mm. So suppose you are at 160 meter altitude, your mercury level will be 759 millimeter. if you are there at 1600 meter altitude, then mercury level will decrease by 10 mm. So we are getting 750 mm of mercury. So this way we are getting lower pressure at higher altitude. As a result, air starts expanding. For this expansion, there is work done or energy requirement is there. That energy is taken from temperature only, which is already there, and from that heat is utilized for this expansion, and so the work done is there, that is called as adiabatic. This process is called as adiabatic process or adiabatic cooling. So pressurized air is there, it is getting expanded, because of that temperature falls. Want to check out? Simple experiment you can perform with me. We have thermometer. Our skin is serving like thermometer. God has provided us compressor also. It is my compressor. I will first compress air and check out temperature. So what you have to do? Simply carry out experiment with me. Take your palm, blow, press it. Check out temperature, you will get high temperature. Why? Because we are compressing air, and as compression we are getting hot. You can say that our body is having 37 degrees Celsius temperature, outside temperature is low, and therefore if air is coming through our mouth, then obviously it is heated. No, but apart from that we are compressing out and then we are getting more temperature. You can check another experiment now. Hold your hand or palm away from your mouth and try to blow again. You will feel cold sense. Why? Because air is compressing your air. The moment air comes out, it gets expanded. For that, work done is there by that whatever heat is there, that is taken out. And as a result, temperature of air decreases. In refrigerator also some similar conditions are used. So when air moves up, at that time automatically it gets expanded and therefore temperature falls. So this is another reason of cooling when air moves vertically up. Again, if air is moist and air is dry, because if air is dry, then only uplift is there and work done is there and cooling is more. But if air is moist, then another concept is there, whatever moisture is there, that start getting condensed out, and for that purpose its temperature fall decreases. So this is lapse rate is different in moist air and dry air. Now see, that's why if you are moving at higher altitude, normally temperature should fall by 1 degree Celsius for 160 meter. But because of this adiabatic cooling effect, we are getting more fall in temperature than expected. Getting idea? So this cooling is called as adiabatic cooling. Now if you are coming from higher altitude to lower altitude, then again same thing is there. Because of lapse rate, we have to work in reverse way, temperature rises. But because if air is coming from high altitude to low altitude, it gets compressed out. And then there is rise in temperature. This is called as adiabatic warming. So both concepts are working over here. So it depends upon air that is coming from lower altitude to higher altitude or higher altitude to lower altitude. Lower altitude to higher altitude we are calling adiabatic cooling. Higher altitude to lower altitude we are calling it as adiabatic warming. So it depends upon air. That means temperature is not only depend on latitude, it depends on altitude, it depends on maritime effect, it depends on continental effect, it depends on what type of albedo are observed by that land. And now we are discussing air is coming from top to bottom or bottom to top. Again, there is a concept that is called as inversion of temperature. We are now discussing that concept, that is inversion of temperature. After my all discussion, it must be clear in your mind that on surface of earth in troposphere, as we are moving higher the altitude, temperature should decrease, and lower the altitude, temperature should increase. But if reverse pattern is observed, then we are calling that as inversion of temperature. What is reverse pattern? Suppose there is mountain. You can expect that on mountain, top of mountain there should be low temperature, and towards valley side, that means towards deeper part of mountain, there should be more temperature. Higher the altitude, lesser the temperature that we should expect. Many time it happens, but sometime it not. We are getting more temperature in the top of mountain and low temperature in the valley. Want evidence? Try to get various photographs. Now on whatever the social media, many photographs are there. You can check out these all photographs, particularly during winter season. If you observe mountain or hillside photo, many times you must have observed that frost or whatever that fog is there, that is towards the bottom of mountain, and mountain top is exposed off. Have you observed this type of photograph? Actually frost should be there on top of mountain and bottom side should be clear, because frost is there because of decrease in temperature, and then droplets are formed. But we are getting this exactly reverse case. This condition is called as inversion of temperature. Now what happen exactly? At higher altitude or upper parts of mountain, many times they are exposed out. No covering of plants, trees that is there. So upper part of mountain usually exposed out. If that is Himalaya like mountain, then obviously above 5000 meter altitude, oxygen level is very less. Atmospheric pressure is also very less, and vegetation is also very less. So you must have observed Himalayan photographs that forest is there at valleys or periphery, whereas mountain peaks are bare. That means they are not covered by grass or by trees. In various mountains, volcanic mountains like Sahyadri, you must have experienced that upper part is having rock cap, whereas lower parts are having forest. As rock is there, there is very less amount of soil and no trees are growing on that, or very rare trees are there, so surface is simply exposed. What is the impact of that? During daytime that become hot. Night time it radiates heat quickly and no covering is there, so it lose out temperature and air get colder. But you are aware that when air is becoming cold, it is getting compressed. Its density increases. What is density? Density equal to mass upon volume. So as it is compressed, volume decreases, density increases. As a result, if there is mountain range like this, here air get colder, density increases, where here the radiations are not that extent. Why? Because it is covered by forest, and that's why temperature fall is not much, and so this air start draining out towards bottom, whereas this air is replaced here. So this way, this is the drainage of cold air from top to bottom. As a result, it is replaced by hot air from bottom to top. This type of inversion of temperature, that is called as drainage inversion. So this is first type, that is called as drainage inversion. Now second type of inversion, that is called as radiation inversion. Due to some reason, if lower areas they are exposed or any other reason, lower areas radiate energy to great extent. As a result, temperature fall is observed in lower areas, whereas higher altitude areas, they retain energy. Let us check out a place, that is Mahabaleshwar, that is there in Sahyadri mountain range, where it is covered densely by trees. It is having dense forest at top, whereas a place which is there nearby, that is Vai. It may be possible that during summer season Mahabaleshwar's temperature may rise, whereas Y will have lower temperature. Why? Because that is exposed land. So immediately radiation is carried out, whereas in case of Mahabaleshwar, it is covered by forest, and therefore radiation is not much. It is retained there, because night time forest also emit carbon dioxide, trees also emit carbon dioxide, and therefore this energy is trapped. So exposed land may radiate energy to greater extent, whereas covered land will radiate energy with less extent. As a result, higher altitude region will have more temperature and lower altitude may have less temperature. This is called as radiation inversion. The third type of inversion, that is called as advection inversion. What is this advection inversion? Particularly this occurs on border where, say, from this side warmer air is coming and this side cold air is coming. When they are having clashes, the warmer air moves in upward direction and cold air remains at bottom. Why? Because cold air is having more density than warm air, and so warmer air moves in upside and cold air as downside. So downside temperature is more and upside temperature is reverse. Downside temperature is less and upside temperature is more. So it is expected that upside temperature should less, but it is more, and downside temperature should more, but it is less. So this is inversion of temperature. This is called as advection inversion. So this type of temperature of inversions are observed here. So this is the part of temperature. Now next topic we are starting out, that is thermal anomaly, in next lecture.